Hello, everybody, and welcome to our ASIP webinar series. My name is Anita Emmersdorfer-Augustin, and I'm an area leader at ASIP of the area Sustainable Production, and it's my pleasure to guide you through this evening today. Today, we have another highly exciting topic for you, which is ethics and AI in biotechnology. And with us today are two experts in this field, Magister Lukas Madl from Innovatic and Dr. Christian Gruber from Inno4. In this webinar today, we will delve into one of the most pressing questions in modern research. How can we actually ensure that technological breakthroughs, particularly in AI and biotechnology, are also guided by ethical responsibility? Our first speaker today is Lukas Madl. He is the founder and CEO of Innovatic, and he is someone who is deeply interested in the question of why ethics should be an essential part of research, especially in fast-growing fields like artificial intelligence and biotechnology. In his talk, he'll share his thoughts on how we can make sure that innovation doesn't just push boundaries, but also stays societally responsible. Interestingly, Lukas is actually a researcher by heart. He started out in genetics and clinical research, but over time he found that his real passion is actually at the crossroad of science, ethics, and innovation. And that's also what led him to found Innovatic, driven by the conviction that technology should serve people and not just impress them. I'm really looking forward to hearing his perspective on the ethical challenges we face and actually will be facing in the near future in research, and how we as a community can take responsibility for shaping the future. So please join me in welcoming Lukas.
Thank you very much, Anita. Thank you for the invitation. Thank you to everybody who is present, and I will just start with sharing my slides. And I guess I have to change it. Is this right, Anita?
Yes.
Yes. Yeah. So that's the topic of today. From my slide, ethical use of AI in science. And actually, this topic is very timely. Just 3 days ago, the European Council has published a paper, a document about strategy, how to use artificial intelligence in science. And they stress that there's a big need to clarify a lot of questions so that European researchers can be move forward fast in really transforming and use the transforming technology. We are talking today not about how to develop AI ethically, which is also a part which we consult on, but we are talking about how to use AI ethically in the research context. So, as the document stresses, there are, as you probably will know, there are many different applications, and we will hear use cases in the next talk from my colleague. How to use artificial intelligence in research and science context. And probably you will also know that there are a lot of different kinds of artificial intelligence, different technologies summarized in the term artificial intelligence, but that's not so much the topic of today. We are just looking how it is used in different applications in research, like analyzing the data, like making simulation experiments, getting a fast pace for new discoveries, and of course Since the launch of ChatGPT, many people, and of course also in the research community, are using large language models just as a supporting tool. So it's a big area, but what we have to look at, and this is also stressing the document, that we should use it responsible. We should use it ethically and also inclusive. And now that's my question. I mean, it's so often said we have to use it ethically, but what does it mean? And so we just look a little bit what actually ethics is. And yes, it is a branch of philosophy reflecting on the question, what is good and what is bad, what is right and what is wrong, what is just, what is unjust. The core of it is just reflecting on the question, what constitutes a good life? What corresponds to the deep needs of human beings? What do they need long-term for a good life? And how this good life can be achieved. And this is actually ethics, or in a broad sense, what ethics means. So primarily, it's not so much what we are not allowed to do. Often it's associated with this topic, what we are not allowed to do. Oh, somebody is talking about ethics and tells us what we are not allowed to do. This is part of it, but only after reflection, what actually is needed that we can live a good life. What do we need? So it's not so much an obstacle for our endeavors, it's an enabler. It's guiding us in the right direction that on the long term, we hope we can live a good life and live in a flourishing society. That's the point. Now, how to navigate this? I mean, we do have thousands of decisions we do every day. How to navigate? And the cornerstones of the question, what is a decision directing in a good, for long-term good life? These cornerstones are what we call values. This is what we are talking about. Values are the cornerstones in the reflection, ethical reflection, and actually are the cornerstones of every civilization, values. And there are values which are so important and understood that they are so important that they are also protected by law, or for example, in human rights. Now, I'm talking now about again, a very new document, which has been published last month in April 2025 by the so-called ERA, European Research Area Stakeholder Group, regarding how to use responsible generative AI in research. And they defined, based on other considerations, 4 values, as I call them, or they call it principles, which are necessary to follow if we want to use AI responsible, which are reliability, honesty, respect, and accountability. And actually, these are basic, again, cornerstones for how to conduct responsible science. Now, just let's have one look at one value, which is the first one in this context, reliability. Reliability. If we look at recent publications concerning reliable science, we see that there is a reliability crisis. This is a book, I think it has been published 2 years ago, about the reliability crisis in science, bias, fraud, and reproducibility. Or this is a paper, AI-generated images threaten science. Here's how research hope to spot them. Or British University warns that AI paper mills are swamping science with garbage studies. Now, if you look into this topic, this is really a critical one. It is about so-called paper mills generated by AI, which means that, yeah, parts of scientific reports or even complete papers are just generated by AI, data are generated, pictures are generated, or papers which are already published are rephrased so that you don't detect it as a peer reviewer that is already based on a published paper. And this is a huge problem currently. Just generating so-called scientific studies out of nothing by generative AI. Of course, this makes a huge problem for trusting in science. It's of course an unfair advantage for colleagues who are actually in a competitive academic environment. It's of course potential harming public if some results are published which are not really scientific results, etc., etc. So we see generative AI is a tool as many other tools, and you can use it for the benefit or for the harm. But also in the context of science, we really have to look how to use it. So that's beneficial for the scientific endeavor. Now the second value which has been mentioned is honesty. And actually, that's very interesting. You even don't have to look into scientific arena. If we look how it works, many people are posting, for example, their curricula or their achievements on platforms, social media platforms. You look at them and say, what's happening here? If you know the person, it could mean that you see that's not what they really did or have achieved. It's just polished and exaggerated, etc., etc. Now you could say, well, people will take it or not. But the additional problem is that that's actually the training data for the future generations of generative AI. They learn from the wrong data, which are presented in the posts. So here we have a so-called Pinocchio effect. The lie is getting deeper and deeper and deeper. And that's actually why it is so important, or it's an aspect why it's so important to get it right. As AI is not so like a traditional machine, it's like a physical object, and a physical object primarily can harm us on the physical level, on our bodily level. If a machine is unsafe, it can explode and harm myself. This we are used to it for generations or centuries actually in our society. However, artificial intelligence and the digital world as a whole, it's not only interacting with us on the physical level, but on the emotional level and then the cognitive level. And it's trained by our emotional output and cognitive output, and it influences our output. And generative AI is like a parrot. It just tells you what is in the internet, more or less. We know problems with bias and hallucinations, etc. But it learns from what is there on the internet, and there are good and bad contents. There are friendly posts and there are hateful posts. There are true and false informations, etc., etc. And everything is feeding into the bots. And we have to do something with it. For example, you use the AI helping you in your research. And in end effect, it will affect an additional person like a peer reviewer, etc., etc. So we're talking about a socio-technical system. If we want to get it right, if we want to get it ethically, it's not sufficient just to look at the technical part, like how it has been trained, how does it work, which models are here in the AI, but how is the context between the humans, which are feeding with their data, the AI, and the output, and what is done with the output. So the ethical considerations are just about the people from the beginning over the algorithm to the people in the output. Now we talked about values. And there are different kinds of values. And this is a hierarchy of values, and I don't go into the details about the philosophical background considering values in a hierarchy. But it's quite simple. There are values which are, we call them extrinsic. They don't have an end by themselves, but they're helping to realize more important values like reliability, honesty, which are, as we said, values of also science. But actually, those values are important to realize actually the pursuit of science, namely to get more and more an understanding of reality in terms of truth. So when we are talking about how to get more efficient in our scientific work, more productive, and using therefore the AI tools, that's fine if we feed into reliable use of it, in honest use, etc. In action to realize and to go for the core value, which is truth. Often, and that's the problem, this triangle, you could say, or pyramid, is turned upside down. We are in a competitive environment. We have to be efficient. We have to be productive. Let's see if I have to be reliable completely, and sometimes I don't have to be as honest as far as I can publish the paper early enough, etc., move on in my career. And in the end, we are using, we are going for values which are at cost of higher, or actually the core values. And if that's happening, we really have a problem. So, what to do about it? This talk is not about if we should use AI. The talk is about how we should use AI. And what we do at Innovatic is just partner with companies, with academics, with universities, to work with them together how to get it right. And this is the so-called value circle which we have developed, starting from the purpose and why should we use AI, in which context, for what purpose? I mean, you will realize that there's so much pressure today. You have to use AI, you have to use AI. If you don't use AI, you will be a loser. But actually to get the strategy right and to have it really, to use it then in the end also really efficiently also, you have to understand the purpose, why to use it, in which context, for what. Now then, we go into this value circle and we consider how should we use it that it really realize positive value, which we are going for, positive value, positive scientific value, positive insight. And also how to reduce risk, which are always accompanied with technologies like that. And the third step is how to get it legally right. And this is a moving circle because you have to do it again and again. If you want to get AI and other technologies ethically and use it ethically, you have to invest. You have to invest yourself, and you have to invest your thoughts and your human oversight. If you don't, you won't get it right. It's similar like if you want to tidy up your room and your flat or wherever you live, you always have to invest a little bit. Otherwise, if you don't do anything, it generates chaos, and it's the same using technologies like this. If you don't look at the ethical part of it, you will get it on the wrong. You will get it wrong. Okay, so which values should be realized and how? This we question and work together with our clients. What is really important? Reliable trust, insight, well-being. Also as a research output, medical, for example. Which values are at risk and how to avoid it? And here we have also to think about energy usage. It's not a big part of my talk today, but probably you will know. Generative AI uses enormous amount of energy for training and also for usage. So please be aware of it. And it's also about de-skilling, which means if we use more and more generative AI and don't critical think what to do it and how to do it, we lose the capacity to write our own text, to think about, to critical overview it, to be creative. So that's a major issue we have to be aware of. And the third part is how to get it on the legally side right. What about the IP topics? What about data protection? How to comply to the AI Act if necessary in this context. So yes, I really want to engage you to think about how to use it, how to use AI in an ethical way to help the scientific endeavor to move forward and really be a positive part, yeah, for our society and the world as a whole, because it's so important that we get it right. As in those kinds of technologies, there's so much power, and with that power comes the responsibility. And I hope I showed you a little bit how you could go forward. Thank you very much.
Thank you so much, Lucas, for this very thoughtful and interesting insights into this matter. I would like to invite all of the people in the audience to stay with us and ask the questions after we had our second speaker present. But thanks in the meantime, and we will see each other a bit later again. And with this, I would actually like to announce our second speaker today, which is Christian Gruber. And I'm also really glad to welcome him. Christian is the founder and CEO of Innofor and has been a scientist at ASIP in many different roles for many, many years, and also is affiliated with the University of Graz. He has a background in biochemistry and holds a PhD in structural biology from the University of Graz. And his research journey has taken him to places like the Royal Institute of Technology in Stockholm and the University of Stuttgart. And in 2018, he took the step and co-founded Innophore, which is a company that actually uses AI and structural bioinformatics to support enzyme and drug discovery. Especially during the COVID-19 pandemic, they even worked with tech giants like Google and Amazon. So Christian's work centers on understanding how biomolecules behave using computational tools. And here, especially AI-based methods like the Catalyphore platform have been established. In his talk, he'll explore how AI-generated synthetic data is shaping innovation in biotechnology, but also addresses the risks that come with it, like data bias, unclear origins, and dual-use issues. With that, I like to hand it over to Christian Gruber.
Thank you very much. Thanks, Anita, for the very kind introduction. Thanks, Lucas, for the very interesting talk. I guess it works, right? You can hear me. Everything is good. Okay, thank you very much. Great. So good thing is we will have much more time for discussion because Lucas did a fantastic job covering, I think, the most pressing issues related to ethics and science. Still, what I'd like to do is I'd like to give a bit of a first-hand impression. As Anita said, what we do in our research and as a company, we make heavy use of AI, but in two ways. The one thing is we create AI. That means we use training data, we create models, and we make that available to our clients and customers and partners, mainly in the field of drug discovery and enzyme research. This is an entirely different but related topic to using AI. Using AI like large language models, other diffusion models, image generators is different because it's not our AI. We have much less influence on the outcomes, but still we use it on a very daily basis. And if you look over the world and compare different continents, you see some kind of gap between the States and Europe, but it also becomes in Europe an everyday tool everybody is using. So when we thought about the webinar, I thought it makes more sense to show you also two use cases where considerations of ethics were relevant in our own research and not so much cover about philosophy behind. But still, one thing that I really found interesting is my first slide had exactly the same lineage as Lucas. If you think about science and AI, it's important to be reliable, you have to be honest, you have to be respectful, and you have to be accountable for what you do. And now I'm not jumping into all of these topics because Lucas covered them very, very well, but I'd like to shed some light on it in our own context. So I'll be a bit quicker on some of the more general topics, but I'd like to emphasize on one specific thing. If you do science and if you do research and if you want to train AI-based models, you need data. And all of you know, laboratory data is limited. So what is state of the art is to do it with synthetic data. That's what I'd like to explain. Then also highlight a few of the benefits, a few of the challenges, maybe also even a short guideline of how you could do it right. And then we'll jump into our very general discussion. So in biotech, we have many different problems, as you know, but most of the time, everything that we do in biotech is based on limited data. We never have all the data that we would love to have. The data is very often sensitive, especially when it comes to patient data. And that's, I think, the most important thing to consider. All the data that we produce is heavily biased. Synthetic data aims for augmenting this while protecting, for instance, privacy. So if you work with patient data, synthetic data means it's based on real-world patient data, but they are synthetic data sets that were generated representing non-existing patients. And this can be that can go so far that this could be artificial genomes. What it aims for expanding the data volume and therefore accelerating your research. and the pipelines. That's the main goal. That's what everybody's heading for. And if you do it right, you even have the possibility to collaborate cross-institutional. That means you collaborate with other companies, with other institutions, sharing data, but without sharing the raw data. What you're going to share in these cases is augmented data that is not entirely true. I mean, true and not true is a philosophical concept, but it's not the original data. And therefore, you have a much easier day when you want to share that. Therefore, balancing this kind of innovations with all of the ethical responsibilities is crucial and has to be considered all the time. So what is this now, this synthetic data? That really means synthetic data is artificial data that's created by computers. And by computers means very different methods can be applied to do so. One thing that is very straightforward, since we have language models, since we do have transformer-based models, we can generate data on scale with AI. But there are other ways of doing so. If you're not using, for instance, AI or machine learning-based methods like diffusion models and generative networks, the things that we know for decades are like physics-based methods. They are very suitable for creating augmented data. In our context, and I'm not going to dive into my research, but in our context, it means there are simulation methods that date back to the 80s. They are physics-based, heavily compute intense, but they can create data sets that you could label as artificial data and therefore improve your training data sets. Other ways of doing so is, for instance, rule-based or agentic-based methods to, for instance, increase your population in the data set. And state-of-the-art nowadays is hybrid methods. That means a combination of machine learning-based methods with physical methods, sometimes using even very traditional scoring functions, but at the end of the day, speeding it up with AI heavily. This is a new field of science and business where billions of dollars literally are currently invested to go beyond the physical data sets that we definitely have to expand to get new models running. So the key benefits of using synthetic data for whatever specific application you're looking for in biotech is you can protect your data, you can obscure your data while keeping, for instance, the statistical contributions and statistical distributions in your data set correct. Therefore, you can protect it in terms of IP. You can tackle issues in terms of the balances. When you need the training data for your AI-based methods, having a balance between good and bad is key. Very typically, this is a long-standing problem in science. If you look at our literature is mainly looking for and mainly communicating the things that worked. If you train a model, it's even more important to have data sets of things that didn't work. Because how should AI or whatever method there is distinguish between what's good and what's bad, and even extrapolate even better versions of, for instance, a protein or a substrate if it has never seen the bad ones? So these balances are extremely important, and synthetic data generation often aims for not producing excellent cases, but producing also bad cases to train an AI in a very balanced way. That also relates, maybe this shouldn't even be two separate points, but that also relates to the biases. It's the same. There are in all of the data sets heavy biases. If you, for instance, go for patient data, the bias can be due to the origin of the population that was studied. European is different than US. Asian is very different in terms of some genetic elements, for instance. Using augmented data, you can create augmented data sets to try to find the balance between the imbalanced content of your training data. Therefore, you can reduce the time, you can speed it up with in silico methods and go to an entirely new field of exploration. I know that sounds very vague, but you will see if you use it that, for instance, you can spend days, hours in looking into data sets that are not real and still give you new insights. And last but not least, what is also important and what's also not often considered is the ability to explore edge cases. That means if you create synthetic data and you don't have edge cases, you can try to create edge cases. What's an edge case? It's far off the average. If you look at sigmas for whatever parameter you're looking at, you can create data sets that are at the entire extremes, at the minimums and of the maximums of whatever you're looking for. And this is extremely valuable for training things. If you now look at these ethical risks, what Lucas also did very intensively, in terms of synthetic data, what we have to look for that there are no real biases, that we can really derive the information that we create from the source data, that we don't mess up with reproducibility, because that's also something that has to be checked, that has to be corrected if it's not wrong. And especially if the origin of the data is not clear or obscured, you cannot reproduce it. Not your own experiments and not the experiments of others. That's a major issue with literature at the moment, especially AI literature. You cannot reproduce the models that are out there as a scientist, just also because the limit of available data, they either didn't publish it or they published versions that are not working. And the second one is, if you look at biology, and I'm not talking about ChatGPT, OpenAI, and the very general language models, I'm specifically talking about foundation models in our field of science. If you would be interested in reproduce the training of EVO1, that's a foundation model, having proteins and sequences and function annotations and everything in, you need literally years of supercomputer that are available to us as researchers. This can only be handled by global corporate companies like NVIDIA internally. So reproducibility is important, it's fine, but to be honest, quite often it's just not the case. The third issue that actually played a role, and we will see that a little later, in one of our own research projects, it's dual use. If you think about ethics, if you think about AI, you could take a data set, you could create a synthetic data set, you can create what you wanted. For instance, you're looking for a cure, you want to cure a viral disease, and fine, you're getting new drugs out. They might work or might not work. But the point that I want to make is you can use exactly the same model to create toxins. You can use the very same model to create nerve agents. And without dipping into that now really deeply, there was an experiment recently, I think last year, where people used generative AI to create nerve agents like Serene and VX, so these really bad ones. And within a few hours, thousands of compounds could be created on a computer. Of course, that's fast, but they also did the work to validate it in the lab. And what came out was many of them work. So we can use the methods that were meant for a good purpose easily for a bad one. And as a scientist, that's a field of, I don't know, we don't really can handle this, but that's also not our job. We make science. Society has to find solutions to circumvent the dual use. And with shifting politics, especially in Europe and the United States, we see an extremely increasing interest in dual use of existing methods, not for warfare, but for protecting against wars. And this is something most people don't consider on a daily basis in their biotech research, but consider that if your models, if what you do or your data sets could be used for, let's say, not the good of mankind. Last thing here on the very general level, if you do synthetic data generation, train AI models, and you don't communicate that well in your articles and talks at conferences, it's not only that you lose reputation, but you harm science in general. That's something, consider that you and I and everything in this sector relies on the society to be trusting into what we do. Otherwise, we won't get money because typically we are funded by the public. And if we set that at risk, our future will be much more complicated. So if you do that, do it right. I'll skip that one and jump over to some safeguard mechanisms before coming to the use cases. When you use AI, when you use generated data sets or artificial data sets, then always do a continuous monitoring of what you do. I know that sounds vague, but there's a lot of literature of how this can be done right. Always validate against authentic data sets to see how far off your not real data set is. Do the metrics, do the maths, and do the statistics. And if you can, watermark your data sets. It means, especially if you generate data, which is not originating from real experiments, you can use methods like steganographic methods and others to hide, for instance, whatever, your watermark in the data. Many people do that. Many corporates do that. You should look into that. And the last 10 minutes, I'd like to spend on two cases. The one is, Anita mentioned that in the beginning during COVID, we were heavily involved in some aspects of COVID-19 research. And one was to look for potential cures. And one potential cure at this time was a decoy. What's a decoy? A decoy is a drug that is applied to patients. And the mode of action is this drug actually does not interact with the proteins of your human proteins, but it tries to cover, in this case, the spike proteins of the virus. Why? If the spikes are covered, then the virus cannot introduce your cells anymore. So what was our duty? Our duty was to create versions of existing proteins that are known to bind to the spike protein of SARS-CoV-2 with an increased affinity, because the more affinity you have, the higher the binding affinity is, the less drug you need, and the higher the potency is. So taking an existing molecule, in this case, it was even a human receptor, angiotensin converting enzyme number 2, but not so important, taking this one and make it better. And we created a pipeline for that. Why? It turned out at this time there were exactly 17 experimentally determined binding constants available. 17 is not enough to train an AI model. Typically, you need hundreds or even thousands. So we set up a traditional pipeline for predicting binding affinities of given variants. How does that work? You collect all the data that is out there for real-world measurements about affinities. As mentioned, it was 17 only. And then you create computer models of other versions that try to replicate the experimental findings. And if you have done that, then you can at least assume your physics-based method can predict the existing ones right. So the ones which are close should be also predictable. So what we did is, that was working with Amazon at this time, we got a tremendous amount of compute. It was almost $1 million to do what's 20 years old, molecular dynamic simulations, to create data that is actually artificial, but it augments the 17 binding constants, the experimental ones. So at the end, we have 2017 binding constants that we used for training a deep neural network. And now you might ask, you have a physics-based method, so why should you look into generating something with the old methods that's very costly? If you once have trained, in this case, the neural network, it can predict affinities much faster than the physics-based methods. So this is the aspect of acceleration. What it means is, after that, we couldn't run 2,000, we could run millions of COVID variants to predict how their infectiousness might be. And that is based really on pure artificial data, just augmented with the 70 ones that were experimentally determined, which actually in the whole balance of the data set didn't even play a role anymore. Does it work? Yeah. There are papers that we published that works quite well, and it was validated in the lab. It's not part of ethics, but whatever you do with AI, always validate it. Otherwise, it won't make any sense. So to summarize this case here, use existing data, find a validated method that generates more of this existing data, ideally on the computer, because it's still cheaper than the lab, and then train a model with it, get the results out, check the results, and validate it. As simple as that. And it is in this specific case, if we look into the the considerations from before, privacy was not a topic. Proteins are not private, at least not at this scale. The dual use, that was important because together with Amazon, we launched a website that predicts the binding affinity of COVID variants. You just copy the genome of a new COVID variant and it will tell you if it will heavily bind like Omicron or if it's an early starter like Delta or whatever. And what we learned by that is if you just generate genomes artificially, you can use that tool for selecting the worst ones. That also means you can use it for what's called gain of function research. So we implemented on the website a feature that is not shown to the public, that if we see that people submit sequences that yield to higher affinities, which look artificial, we block the generation. That means it's not fully transparent, but it's a safeguard because it can be used for dual use application. In terms of transparency, we just declared that. In the paper, we wrote a method section, how we generated the synthetic data, and all is good. Nobody has any feelings about it. But you have to declare it clearly, because otherwise people might trust into your data sources, and then it turns out you had troubles in your simulations or a wrong force field, and it doesn't make any sense. So it's still less, I would say, qualified data than real lab data. That basically summarizes it. It's more for reading it later. So if you do it, be transparent. If you do it, be honest. Talk about it and also be proud of it. There is no harm if you generate data. It's just harmful if you don't declare it. And the second case that I'd like to show you is not similar. It's actually different, but it's in the same field. That's AlphaFold. AlphaFold is a fantastic predictor of protein structures. It has revolutionized our entire field, and that's not a joke. It can predict protein structures in a scale we couldn't do before, and therefore, the team that did that got a lot of attention. They got Nature papers, cover pages of Nature, and last year they even got the Nobel Prize. So at least two of the shared chemistry Nobel Prizes went to Hassabis and Jumper. These are two guys from DeepMind, from Google. So it's important. It's super important for the field. So why should there be any ethics considerations? If we look into that, AlphaFold is making mistakes. And that's fine. Research does make mistakes. Computers do make mistakes, and we do all the time. But AlphaFold has the intrinsic, let's say, behavior that it will not tell you. It will, for instance, if you give a compound, a molecule that is chiral, that's the story with the enantiomers, like the two hands. If you give one enantiomer as a substrate or a ligand to AlphaFold and let run the diffusion process, there is a high chance, or at least a certain chance, that it will invert the molecule. You'll get the other one out. That's a mistake. That's based on how the model was trained. That's all good, but it will give you a very high confidence on what it was doing. If you're now a chemist, and we are chemists, we looked at that, we were confused, we looked in the primary publication, and they claimed in their statistical analysis in the supplementary part of the original AlphaFold paper in Nature, somewhere, that under certain circumstances, they do have under certain blah, 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 a certain amount of chiral inversions. That was just a side notice. But in reality, inverting chemistry, like stereochemistry, if you look at molecules that are important, for instance, drugs like Contergan in the 80s and 70s, that might cause dramatic problems if you do that wrong. So how can that be handled? It should be handled. It should be treated more severe. And I think they might have had to look into that more deeply. We actually, after we found that, we summarized it and submitted it to Nature, and they immediately after what, I think 10 days or 14 days, they published the correspondence where we said, okay, AlphaFold is really fantastic. You can work with it on scale and on speed, but they don't always get the chemistry right. So it hallucinates, and it will confirm that it's right. And if you ask this question again, are you sure about that? It will again give you the wrong answer. So a solution for that is, and my first solution is they should do it right. But second one is human oversight is still needed. And it's easier said than done. If you have one protein and one ligand, okay, just look at it. If you have millions, how should you? So you should implement testing routines to your AI-based workflows that test it with other methods all the time. Currently, there's a big boom in agentic AI, and agentic AI can be augmented with non-AI considerations. You should do that, especially if you do research. You should be very transparent about your error rates. And if you create a model that wins the Nobel Prize, it would be also totally important, maybe even to have our own paper about the failures that the model can deliver, and not only the landing page of Nature and the cover page. So be transparent on that one, and be very critical, especially if you already have won a Nobel Prize, then you can be very critical against your own research because you've reached everything anyway. So be careful and try to get the things right. So the researcher's checklist that I would like just to share with you is be rigorous in validating it, be transparent in documenting it and communicating it, do some review in governance, and that can be done by deep research. Use the help of large language models to evaluate your own work and communicate to your stakeholders, to the universities, to your PIs when you use AI. So synthetic data is super powerful. There has to be a diligence if you use it. Be transparent and be responsible for what you do. With that, I think we can have a discussion. I'll stop my sharing my screen, and thanks for your attention.
Thank you so much, Christian. This was also a fantastic talk. I see Lucas also agreeing with me. I think the two talks were just perfect, also how they were aligned. All right, so now we can actually start into our Q&A part of the webinar. And so there's now two options. You can either post your question into the chat and I will read it out loud, or you can raise your hand and switch on your camera and then you can ask directly. And while you are typing and putting in your questions, maybe which, as I know, often takes a little bit of time, I would actually like to make a quick announcement for our upcoming webinar, which will be held on Tuesday, June 10th from 3 till 5 in the evening. We have two speakers. The topic will be mechanistic modeling in virus filtration. And speaker number one is Dr. Hironobu Shirataki from Asahi Kasei Medical Company from Tokyo. And the second one is Professor Ranil Vikrahamsinghe from University of Arkansas, USA. And now please stay here with me and let's chat with Lucas and Christian. Oh, good. Lucas has already a question. Please go ahead.
Thank you so much, Christian, for this wonderful talk. My question is regarding in the context of your research and synthetic data, what do you actually mean by mitigate bias? As bias is not only a mathematical term, but if you're saying something is biased, we say the outcome is unfair. But what would it mean to be an unfair outcome in let's say, biological molecules, proteins? So could you elaborate on this?
Sure. I mean, there's one category where it's maybe easier to understand unfair outcomes in terms of biased trained data and artificial intelligence methods in terms of drug discovery. If you have a data set that represents only a certain part of the population, the drugs might not also work for another part of the population. Yeah. That's typically this kind of patient stratification strategy, and companies now use AI to balance that. If you have a drug that you want to sell globally, it should work for everybody. So there is a bias with an unfair outcome. In terms of biotech research, not related to humans, it's not so easy to detect, but maybe just out of the nothing, You're looking for proteins to carry out a certain chemical reaction, biotransformation. Your training data set was heavily, let's say, based on a data set of proteins that work under normal circumstances, like room temperature. And there would be proteins that would do the job just with 10 degrees of Celsius more. If that wasn't included, the outcome in terms of which substrate could be converted could be unfair, because it could say there's no protein that could do the job right, because you haven't seen the ones that could do it. So that might go into this bias in biotech, but very high level. And the last example was really just out of the nothing. The first one is proven with literature.
Thank you.
Cool. We also have a question from the audience, asked by Barbara Petschacher, and she's first of all saying thank you for the wonderful talks. And she has a question for Christian. So she asks, out of curiosity, did these abuse cases in the COVID example where you implemented the blocking really occur?
Yes, but we don't think because of somebody really wanted to do that kind of research. It was out of curiosity if it could be done.
Okay, thanks. And then Margit also has a question, Margit Winkler. Many thanks for pointing out the importance of negative data. Is it possible to augment a data set with negative data points?
It's one of the toughest things to do. Typically, it's not. What we see with partners is more important than trying to generate a data set with a balanced data set with negative data. Try to get the negative data from the lab, and your partners might have that. Corporates and companies, they do have basements where they store a huge amount of information about things that never worked. They're just not published. Try to get that and then use it as a basis for creating a balanced data set regarding negative examples. Just out of the nothing, it typically doesn't work so well.
Thanks. So far, there's no further question, but then I can ask one, and it's, I think, a more broader question. I'm always wondering, that AI is infiltrating each and every field more or less, and also, also in diagnostics, for example, diagnosing cancer. And as the two of you also pointed out, AI makes mistakes, right? But how I think in the different fields, it has differently severe impacts. So for example, if a cancer is diagnosed wrongly or it's overseen, who is actually made reliable for that? Is there can you give a perspective on that? Or also, when a prediction is made wrongfully in whatever?
It's still the doctor.
Yeah.
Currently the doctor. I'm not sure how long it holds, actually. And that's a concern. I'm working also in research with research organization, developing AI for patient monitoring, etc., with physicians. And the question is, we call it responsibility gap. Who is responsible, actually? If, for example, an AI tells you, I don't know, there's a positive diagnosis. The patient has some cancer, and the doctor says, no, there is no cancer. We don't have to do anything. How long will it hold that he doesn't get liable for his decision to do nothing? So that's really, and it's a hotly debated topic in academic community, or also how to handle this on the long term. And I don't think there's a simple solution, but I think also that actually there has to be a human, or at least an organization, liable for an outcome. It can't be an AI, actually, because an AI is not a person. She can't be responsible. She's just trained. She has no conscience. So, but of course, you can say that the company producing an AI and putting on the market, this is liable for what the AI is doing. This company, or yeah.
Christian, do you have to leave, right?
I'm on the jump. Thank you
All
very
right.
much.
Thank you so much for coming today.
See you soon.
See you
Thank
soon.
you.
Bye-bye.
Goodbye.
Bye-bye.
I have another question, but it seems to be a bit about biotech. I will still read it out loud, but it's from an anonymous source. And so it actually says, why are we so concerned about ethics if we want to have a better society? Not many people understand biotech. Why don't we understand better than them and make decisions for them? Why don't we take control of the world, but in a better way?
Could you display the question so that I can read it?
It's a very, if I can show it, right? Or should I read it again?
It would help if I could read it. If you share.
Sure, I can put it into the chat. It's a really long question.
Why was I considered that? Why don't we understand better than them? I don't understand this and make decisions for them. Why don't we take control over the world, but in a better way? I mean, power is always in the danger of misuse. And so if you think you decide what is better for the world without reflecting it together, history has shown us that it always gets into, most times get into a very bad direction. Usually the dictators think they're doing the right thing for the world. If you would ask Putin now, he would tell you he's doing the right thing for the world because the West is bad and Ukraine is bad. And so he's doing the right thing. It's just an example. So it's very dangerous to decide over other people what is best for them if you have more power. Usually, you don't act then on a long term ethically, but very egoistically. And that's why we need law, for example, so that law is protecting us from those goals, egoistic goals of people, so that we have the strength of the law and not the strength of the powerful. And we could say, yeah, I mean, if you're a scientist and understand biotech, it doesn't mean that you're an ethical person. It just means that you understand biotech. And so you have to reflect on it, and you have to get in dialogue with other people's reflecting on it. What does it mean to be a good person? And especially in biotech, it's a huge challenge nowadays in terms of what do we really think is good life in terms of biohacking, in terms of transhumanistic ideas, etc., etc. But in my view, they're very flawed. They're very not philosophical based, those ideas, but that has to be clarified and discussed and get into the dialogue. But as I've said, it's always danger if you think you have got it right and you decide because you have the tools in your hand.
Wonderful. That was very well explained. Barbara Petschacher has another question, and I think it actually follows up on what you just said. It says, it seems to me that the gap between people that know at least to a quite high level how AI works and what benefits and risks are coming with it, and the large mass of people who really know very little about it is very large, larger than with former technologies. What can or has to be done to handle this?
So many people don't understand AI and don't understand the opportunities and risks. Yeah, I think so too. And I think, I mean, as I've presented the paper, for example, one column of initiatives would be to educate people, and actually it's also a requirement of the AI Act. Paragraph 4 tells that organizations using AI and developing AI have to educate their staff. I think that's true. The interesting point is that AI is very overwhelming and so fast-moving technology, and it's very difficult to keep up, understanding what's really going on. And on the other side, ethics, in my view, it's reflecting about those issues, what means good and what means bad, etc. In schools and wisdom traditions for thousands of years. And this actually has not changed so much. So if we get more into the depth of ethics, we can find answers also for the challenges of current technologies and the fast pacement of those technologies. But we have to bridge the technical knowledge with the ethical reflection and insight.
Wonderful. I think those were the perfect closing remarks, I would say, for the webinar format that we chose for today. I also don't see any further questions from the audience. Mm-hmm. So with this, Lucas, I would like to thank you again. Also, of course, thanks to Christian, he already left. However, I hope that we once get the chance to meet in person. I feel that we do and we will, because this topic will stay very relevant. And with this, thanks also to the audience. Thanks everybody for joining, and the best to all of you.
Thank you, Anna. Goodbye.
Bye-bye. See you soon.
Bye.